hundreds of people have had to leave their homes over fears over a volcanic eruption. More than 1,000 earthquakes have hit.
In the heart of the Atlantic Ocean, cradled between the majestic Greenland and Norway, lies Iceland, a rugged island of unparalleled allure near the Arctic Circle. Enigmatic and awe-inspiring, this landmass, comparable in size to the combined expanse of Kentucky and Virginia, unfolds a tale of untamed beauty and geological wonders. With some of the world's most active volcanoes and vast uninhabited landscapes, Iceland emerges as a canvas painted with dramatic plateaus, formidable mountain ranges, and fertile lowlands adorned with long, deep fjords and glaciers, including the significant Vatnajökull. This youthful realm is a harmonious blend of nature's grandeur, featuring cascading waterfalls, erupting geysers, otherworldly black sand beaches, and peculiar boiling lava fields that echo the planet's primordial forces. Yet beneath the surface of this captivating narrative, a recent revelation has stirred the scientific community, a discovery that sends shockwaves through the landscape, intertwining intrigue and alarm. What has just emerged in Iceland? What groundbreaking discovery has unfurled, echoing through the very bedrock of scientific understanding? Could this finding reshape the narrative of Iceland's geothermal wonders, or does it unveil concealed dangers lurking beneath the surface? Join us on Universal Narratives as we embark on a captivating exploration of this mysterious revelation. Iceland, nestled in the North Atlantic like a jewel of geothermal power, presents itself as a country with unique and breathtaking characteristics. With its 103,000 square kilometers, this young land formation is a vibrant mosaic of landscapes. While the majestic Vatnajökull glacier dominates the interior as Europe's largest, the terrain unfolds with spectacular waterfalls, sparkling geysers, black sand beaches, and lava fields, testament to the incessant volcanic activity that has shaped every inch of this fascinating island. The volcanic ballet in Iceland is the result of its strategic position between the mid-Atlantic ridge, the meeting point of the Eurasian and North American tectonic plates. This incandescent geological region fuels a constant symphony of seismic and volcanic activity, turning Iceland into a dynamic laboratory for Earth scientists. A notable volcanic chapter in Iceland's recent history was written with the eruption of Vatnajökull in 2010, an event that captured global attention with its towering ash column, paralyzing air traffic in Europe for weeks and generating worldwide impacts on millions of travelers and the economy. However, what has emerged in Iceland has raised concerns among scientists. Vatnajökull is just one of the many prominent volcanoes on the island, including Hekla, known in the Middle Ages as the Gateway to Hell, and Katla, an active volcano hidden beneath the Mýrdalsjökull glacier. Among others is Grímsvötn, Iceland's most prone volcano to eruptions, located beneath the Vatnajökull glacier. These volcanoes are not only agents of destruction but also creators, providing a significant source of energy and heat through geothermal power for the entire nation. The relationship between Iceland and its volcanoes constitutes an intricate interweaving of wonder, respect, and stimulating scientific inquiry. These natural colossi are a constant reminder of the dynamic nature of our planet and the profound impact that geological forces can have on our civilization. Recently, in the tranquil yet fascinating Icelandic topography, a discovery has emerged that has sparked both the interest and alarm of the scientific community. This revelation, situated in the historically rich area near the small village of Ægi in Rangárvallasýsla, has opened a new chapter in understanding Iceland's geology and history. The initial discovery stemmed from a standard archaeological excavation conducted by the Icelandic Archaeological Institute. What has been unearthed is a man-made cave, previously unknown and dated to the Viking Age. This finding not only was unexpected but also holds significant meaning for its potential historical value. The investigation, initiated in 2018, has revealed a complex of caves much larger than initially anticipated, connected to a more extensive network of underground structures. Local experts hypothesize that these caves not only served as medieval shelters, but also as spaces for livestock and horses. The scope and complexity of this cave system indicate that it played a central role in the community's life during the period of the medieval Icelandic Commonwealth. These findings corroborate the narratives present in the Legends of the Saints by Bishop Thorlakur Runolfsson from the 13th century, which mention similar structures. Direct observers from the archaeological team were astonished by the size and sophistication of this cave system. According to their accounts, the interconnected caves date back to the period between 800 and 1600 AD, coinciding with the Viking Age. This time span represents a phase of significant settlement and development in Iceland, and these caves provide a tangible link to that era. The discovery goes beyond mere historical interest. Currently, scientists raise broader questions regarding this finding. Could there be other similar structures hidden beneath the Icelandic surface? What insights do these caves offer about the lives of the early settlers in Iceland, and how they could have constructed such complex structures with limited technological resources available at the time? This discovery has not only captured the attention of historians and archaeologists, but has also fascinated the general public. It sheds light on a lesser-known aspect of Iceland's rich history, offering a glimpse into the lives of its early inhabitants. As excavation and research operations continue, it is possible that further secrets buried in the Icelandic landscape will come to light, contributing to integrating new pieces into the puzzle of this fascinating island nation's past. The recent discoveries in Iceland have triggered resonating alarms within the scientific community. While they have infused enthusiasm among historians and archaeologists, they also present potential risks and uncertainties that concern experts. The identification of a vast system of man-made caves dating back to the Viking Age has captured the attention of archaeologists, but also raises potential risks. The stability of these ancient structures emerges as a matter of primary concern, especially considering their age and recent discovery. The risk of collapse poses a threat not only to field researchers, but also to the surrounding environment. Additionally, there is a possibility that these caves may harbor unknown pathogens or hazardous materials dating back to the Viking Age, posing a risk to the health of those exploring them. The theory of Icelandia, a submerged continent that could extend from Greenland to Europe if proven valid, would challenge long-held beliefs about the composition of the Earth's crust in the North Atlantic area. The recent discoveries have also stimulated research on the potential impacts of these geological events on climate change, with scientists exploring how emissions from volcanic activity in Iceland may affect global atmospheric conditions. This research is crucial for understanding the role of volcanic activity in climate systems and for developing more accurate climate models. Finally, there is an emphasis on sustainable and responsible tourism in response to these geological phenomena. With an increase in visitors drawn to Iceland's unique landscapes, authorities are working to ensure that tourism activities do not harm these sensitive geological sites. This involves regulating access to certain areas, promoting eco-friendly tourism practices, and educating visitors on the importance of preserving these natural wonders. The response to the recent geological discoveries in Iceland is a comprehensive effort involving continuous monitoring, emergency preparedness, international cooperation, research on climate impacts, and sustainable tourism practices. These measures are essential for protecting communities, advancing scientific knowledge, and preserving Iceland's unique geological heritage. Thank you for watching this video. See you in the next episode. Historical preservation. From a geological perspective, the discovery requires extensive research and study that could provide groundbreaking insights into continental drift and plate tectonics. A deeper understanding of the distribution of continental and oceanic crusts in the North Atlantic area is crucial for accurate predictions of volcanic activities and seismic risks. The alleged presence of Icelandia, if confirmed, opens up new horizons for scientific research, but at the same time raises important ethical and environmental questions that require a thoughtful and responsible approach. These discoveries also challenge established geological theories, prompting a reassessment of our current understanding of Earth's formation and processes. This could lead to new discoveries and theories in geology, extending well beyond the North Atlantic region. While the discoveries in Iceland are fascinating, they bring along a range of ecological, environmental, and geological concerns. As research progresses, it is crucial to balance the excitement of discovery with the responsibility to safeguard delicate ecosystems and the rich historical fabric of our planet. These discoveries are not only fascinating in themselves, but also shed light on past geological events that have shaped Iceland's landscape and influenced scientific understanding. Iceland's geothermal history is marked by numerous volcanic eruptions and seismic activities, a testament to its location on the mid-Atlantic ridge. One of the most notable recent events was the 2010 eruption of the Vatnajökull volcano, which caused significant disruptions to air travel in Europe and drew global attention to the potential impact of volcanic activities in Iceland. It highlighted the interconnectedness of natural events and human systems, underscoring the need for comprehensive scientific monitoring and preparedness. The current discoveries of Viking-era caves provide a direct link to Iceland's past, reflecting the island's long-standing interaction with volcanic activities. These caves, believed to be of human origin, offer insights into how early settlers adapted to and utilized the volcanic landscape for their needs. Their discovery reveals a new level of understanding of Iceland's intertwined human history and geological past. This perspective challenges ingrained conceptions of the formation of the North Atlantic region and suggests a re-evaluation of previous geophysical models. The hypothetical existence of Icelandia recalls significant past geological discoveries in Iceland, each of which has altered scientific perception of the region. By comparing these recent findings with past events, a distinctive pattern of Iceland's geothermal activities emerges, revealing innovative scientific data. Each event, whether an eruption like that of Vatnajökull or the discovery of historical sites, contributes to a deeper understanding of the region's geology and history. Furthermore, such discoveries highlight the importance of closely examining and monitoring Icelandic geothermal activities. Previous experiences, such as the widespread impact of the Vatnajökull eruption, have guided improvements in monitoring systems, stronger preparedness for volcanic events, and a more detailed understanding of the global implications of these activities. The echoes of Iceland's past, emerging from ongoing geological studies, continue to shape our current understanding and response to these natural phenomena. The connection between historical events and new discoveries not only enriches the scientific narrative of this unique island, but also enhances our readiness for future geothermal activities. These recent discoveries are not isolated, but part of a broader panorama of global geological and environmental changes, highlighting how localized events can have far-reaching consequences, especially in relation to climate change. The discoveries in Iceland serve as a reminder of the dynamic nature of Earth's geology, demonstrating how shifts in one part of the world can provide clues about the past and future of our planet. The discovery of Icelandia, for example, challenges established theories about continental drift and the composition of Earth's crust, opening the possibility of rewriting the geological history of the North Atlantic region. Furthermore, such events in Iceland highlight the interconnectedness of Earth systems. Geological activities in one region can influence global patterns such as ocean currents, weather systems, and even climate. The potential implications of these Icelandic events are particularly relevant in the context of climate change. Earth's geological processes play a crucial role in the global climate system, and understanding these processes, especially in geologically active areas like Iceland, is essential for anticipating future climate patterns. For example, volcanic eruptions can release significant amounts of greenhouse gases, but they can also have a cooling effect by reflecting sunlight away from the Earth's surface. Additionally, the discovery of these new geological features in Iceland could offer valuable insights into the Earth's past climate, thus contributing to the development of more accurate models for predicting the planet's future climate. This knowledge is essential for preparation and mitigation of the impacts of climate change. The recent geological discoveries in Iceland not only generate interest at a local or academic level, but also have significant implications for our global understanding of geology and climate. These findings remind us that our planet is a complex and interconnected system, where events in one region can have global effects. As we continue to face the challenges of climate change, the lessons learned from Iceland's geological dynamics will undoubtedly contribute to our global efforts to understand and protect our planet. In response to the extraordinary geological discoveries in Iceland, Icelandic authorities and the global scientific community have implemented various proactive measures. These strategies are designed to monitor, understand, and mitigate potential risks associated with such phenomena. The approach is multifaceted, involving continuous monitoring efforts, emergency planning, and international cooperation. A key strategy is the constant monitoring of geological activity, led by the Icelandic Meteorological Office through a network of seismographs, GPS stations, and other sensory equipment. These technologies allow for real-time data collection and analysis, essential for early warning systems. Additionally, satellite imagery and aerial surveillance are employed to monitor changes in the landscape, such as the formation of new volcanic fissures or the movement of tectonic plates. Icelandic authorities have also developed comprehensive emergency plans in collaboration with civil defense agencies, including evacuation procedures, public awareness campaigns, and coordination with local and international emergency services. The goal is to ensure that communities residing in geologically active areas are prepared and able to effectively respond to eruptions or other geological hazards. Another significant aspect of the response is international collaboration, with Icelandic scientists working closely with colleagues around the world, sharing data and research findings. This collaboration extends to institutions such as the United Nations, the European Space Agency, and various geological and meteorological organizations. By pooling resources and experiences, the global scientific community aims to deepen understanding of Iceland's unique geology and its global implications. The recent discoveries have also stimulated research on the potential impacts of these geological events on climate change, with scientists exploring how emissions from volcanic activity in Iceland may affect global atmospheric conditions. This research is crucial for understanding the role of volcanic activity in climate systems and for developing more accurate climate models. Finally, there is an emphasis on sustainable and responsible tourism in response to these geological phenomena. With an increase in visitors drawn to Iceland's unique landscapes, authorities are working to ensure that tourism activities do not harm these sensitive geological sites. This involves regulating access to certain areas, promoting eco-friendly tourism practices, and educating visitors on the importance of preserving these natural wonders. The response to the recent geological discoveries in Iceland is a comprehensive effort involving continuous monitoring, emergency preparedness, international cooperation, research on climate impacts, and sustainable tourism practices. These measures are essential for protecting communities, advancing scientific knowledge, and preserving Iceland's unique geological heritage. Thank you for watching this video. See you in the next episode.